Yeah, so let me share my screen again. Let me know once you see it. And yeah, so this is where we started from last time. We'll just go through it quickly and then start with our new things. So memory organization. So what does memory organization say to us is that this is our internal ROM. Okay, ROM is our program memory. Okay, program memory. And if we are to use our internal ROM, okay, we have to set EA is equal to 1. Okay, in this case, what it does is internal plus external. Both the ROMs are considered. Okay, so internal ROM will addresses will range from 000H to 0FFFH. Okay, whereas if there is connected external memory, then H to FFFH. Okay, so these are the address ranges. Last time we also saw the decimal to hexadecimal conversion of the numbers and how it really works. Okay, so this is about like when EA is equal to 1. Now, for those who don't know what is EA or don't remember what is EA, so EA is one of the pins in our microcontroller. Okay, so when this pin is set to 1, the microcontroller is going to consider internal plus external memory as a whole, and when it is set 0, it is going to consider only external memory. So how much of external memory can we connect to microcontroller, which is 64-bit, and how did this number come into the picture? Okay, let's say my microcontroller is 8-bit microcontroller. Okay, then how will it work then? It will be, I guess, let me just, sorry, let me just do this. Okay, so suppose my controller is 8-bit controller. Okay, then okay, and okay, so 2 raised to 16. Yeah, so suppose I have 8-bit microcontroller, then uh, suppose I need to interface external memory. How will you determine till like what the memory addresses could be accommodated by my controller? It will come with this calculation to 2 raised to 8. Okay, 2 raised to 8 is how much? So this is the range of address. I mean, if whatever it comes, these are the addresses that my microcontroller can accommodate. Okay, because it's 8-bit microcontroller. So if it's 16-bit microcontroller, then it's of course 2 raised to 16, which comes around 65,536 addresses. That's count came. 64 KB का memory हम interface कर सकते हैं maximum, because these are the addresses my microcontroller will be able to host using its address bus, because it has 16-bit का address bus. It has 8-bit का address bus. So that's the thing. Then we went, a bit deeper into the memory of our controller, and in register banks and how do we select that. We saw a glimpse of that. So register, there are 4 register banks for these memory locations, and we consider them according to our need. And when nothing is selected, definitely register bank 0 will be selected, because to select the register bank we have to, I mean, these modes work like this: 0, 0, 0, 1, 1, 0, and 1, 1. So there is one SFR, okay? There is one special function register. So we can modify, it is PSW, okay? So we can modify bits of these register to select the register bank that we want to use in our program further. So if we want to select register bank 0, the first two bits should be 0, 0, 0, 1, 1, 0, 1, 1 according to our needs. So this is how we select it. So a value upon reset is of course 0, 0, 0, 0, 0. So when it is 0, 0, register bank 0 is gonna be selected. Okay, that's how it works. Yeah, we'll went through this. Okay, then we started with assembly. Okay, assembly language programming. Okay, assembly is a machine level language. Okay, and what you write your code in is C or Java, that is different. Assembly is actual machine level language. Okay, and which actually has the commands. Okay, like this: CPL, SJMP, LJMP. So we just went through these commands and we started with some smaller codes. Okay, so it is CPL. CPL is complement command. CPLA means if my accumulator is having 1, after this CPLA will do accumulator is equal to 0. Okay, so this is how it works. It complemented. Okay, then SJMP. Okay, SJMP is jump. Okay, it is a small jump and it's a large jump. So why do we have two commands for jump? It is because it is a smaller jump and it's a larger jump. Okay, so if the jump is shorter range, like typically 127 bytes from the current address, then SJMP, or LJMP is when the jump is larger than this. Okay, SJMP, LJMP. Then DJNZ. Okay, DJNZ. What does it say? Is decrement and jump if not 0. Okay, so decrement this register, decrement content of this register, and jump to the label if this is not 0. Okay, so how it works is like this. Okay, suppose my R0 is having 5. Okay, my R0 is having 5. How DJNZ work is, we are comparing it with 0 continuously. Okay, we are decrementing R0 first. In first loop it will become 4. Okay, and if it will compare if it's equal to 0, it's not equal to 0, then it will again jump to loop. Okay, what does loop say? Loop is again decrementing. Loop is again decrementing R0. Now it will be 3. Is it equal to 0? No. Then it will again go to loop. It will become 2. Is it equal to 0? No. Again loop. Is it equal to 0? No. Again loop. Now it will become 0. Is it equal to 0? Yes. Condition satisfied. Then it will come out of this. Okay. And it will continue the regular execution. This is how DJ and Z works. Okay. Decrement if not 0. Decrement this register and jump to the label. This is the syntax. Again, JNZ we have. This was DJNZ. This is JNZ. Okay, it is jump if not 0. It is simply a comparison. Instruction. It doesn't decrement anything. Okay, these two are same, but this decrements first and then compares. It directly compares. Okay, so we are moving 10 to our R0 now. The R1. R1 is having 10 in it. Okay, then what does loop says? Decrement R1. R1 will be 9 now. After this, Gen Z loop. jump if not 0. Is R1 equal to 0? No. So it will again come to loop, and similar way it will loop. Again, decrement R1. So R1 will be 8 now. Is it equal to 0? Is R1 equal to 0? No. Then again do. So this is how it works. So purpose of ORG directive. Okay. So ORG is the origin. Okay, origin where the main function should load, where the actual address should start from. Okay, so so why should we always use org 0000h in our code? Is because the reset vector. Okay, this is the reset vector of many microcontrollers. So when power on reset happens, okay, or when we press the reset button, or when the controller is powered on, this is the address it starts executing the things from. So that is why this is important, and there are some other things are listed, you can go through. Okay, now again, like after seeing all the basic instructions, we went through this code. Okay, this is basically a blinking code. Okay, not basically LED, anything you connect to the port 1 of microcontroller. Suppose this is my microcontroller and this is port 1. So what we are doing, we are making it 1 1 1 1 1. We are giving some delay. We are again making it 0 0 0 0. So it is very obvious that if you connect LED, okay, if you connect LED to, this is a symbol of LED, don't get confused. If you connect LED to port 1 any pin, then it is making, if you give 0 it is off, if you give 1 it will blink. Okay, so this is that code. Okay, and we'll go through this quickly because few people requested me to go through codes again as they were upset. Okay, so I told you org directive. Okay, because it starts from 0 0 0h, then main program has started. Now this start is a label or a function, you can say. Okay, to simplify. Now first we are making port 1 high. Okay, moving higher values to port 1 0xFF. Now when we write code in assembly, we usually give hexadecimal value like this. Okay, 0xFF or 0x1a, 0x2a, 0x10, 0x09, like this. Then call wait. Now we are jumping to wait label. Where is wait label? Here. What is wait label doing? It is generating some delay. Okay, generating delay for us. Okay, and how much is this delay? We can calculate this delay. Okay, we can calculate this delay based on the time these instructions or the cycle these instructions take to execute. Okay, so we know move is a 1 byte instruction. Again move, then DJ is NZ is 2 byte instruction. So based on this we can calculate machine cycle, and based on that we can calculate the time this delay has provided. But this is pretty much random delay that we are providing here. If we want to provide the delay of some fixed time, then there are some calculations which we are going to see in next lecture, which we load into our tmod and tcon register in order to operate the timer on the set frequency and time. So but so far let's focus on generating delay this way. Okay, first of all what we've done is we have moved uh, 30. Okay, we have moved 30 to R2. Okay, and 200 to R3, 200 to R4. Then what we are doing, we are decrementing all these three and jumping to specific labels. Okay, here first of all we are decrementing R4 and waiting here itself until it becomes 0. Once it becomes 0, we are jumping to next instruction wherein we are decrementing R3. Okay, we are decrementing R3 which is loaded by 200. Okay, and jumping to wait 2 means again R4 is getting loaded. Okay, means R4 is getting loaded 200 times. Okay, because R3 has 200 value. So R4 will go from 200 to 0 almost 200 times. Okay, because we are again jumping to wait 2. Then again R3 and wait 1. Sorry, R2 and wait 1. So what does R2 has? R2 has 30. So this whole thing will work 30 times, means this 200 into 200 into 30. So this is how much is this delay overall. And then we are returning back. Okay, where is where will we return? Here. Okay, because here is where, I'm so sorry, because here is where we called our wait thing. Okay, the delay routine. So return addresses will send us back here. So what we are doing here, whatever is the content of port 1, which is 0xFFH, so we are transferring that to accumulator. Now accumulator will become 1111. Then we are complementing this state of accumulator, means now accumulator will be 00000. Now again what we are doing, again we are transferring accumulator ka content to port 1, means this 00 will be gone to port 1. Okay, then we are again calling wait and we are doing sjmp start. Again we are jumping to start because it has to be continuous action, it should not stop. Okay, so uh, let me just quickly take you through the code in this software. Okay, okay, so for all those who just joined today and weren't there the last time, this is the ID we are going to use. Okay, so this is Keel. Okay, this software is called Keel and it is basically used to code all the controllers. Okay, so this is we are writing in assembly. We're going to see some codes in C as well. Okay, so but so far just focus on this is the code which you are seeing on the slide, which I just explained. Okay. Yeah, that's the same code. So I just created a project. Okay. Normally the way you create project in any IDE. Okay. New microvision project, and then next create a project, then new file. Okay, you write your code in this new file, you save it, and the process changes here. Okay, then we have source groups here, and under this source group we have our set targets. Okay, so you might have noticed I removed some files from here and then again added led_blink.asm here. .asm is the extension of this file. So what I did is basically I saved it and I added it as a target and I build all the rebuild all the target files. Okay, this is build. Now I'm debugging it. So okay, port 1 is of our interest right now. Okay, so you will actually see port 1 blinking. Okay, see this is the kind of simulation. See it. So one more smaller simulation I wanted to show you guys. First of all, respond to me. I want to know if you're still there and you understood it so far. Hello, hello, hello. Can you guys hear me?
Yes, sir.
Yes, sir.
So you are understanding this, right?
Yes, sir.
Okay. Okay. So One more. Okay, let me first remove this loop. Okay, this is again another simulation software. Okay, this called Proteus. Okay, and what does Proteus do is Proteus is basically simulation software wherein we can simulate all the things we do. Okay, we can implement exact hardware over here and put our code. Okay, suppose this is our code. Okay, then I go to project settings. I click on output, create hex file. Okay, hex file is the file that you actually download on your hardware in order to run the code in embedded systems. Okay, so when I build this target files, it says creating hex file and it says location objects and trials.hex. Okay, so the name of hex is target trials.hex. Okay, so one project one similar name का hex file will be generated. तो तुम लोगों को अगर हेक्स फाइल अलग अलग क्रिएट करनी है तो अलग अलग प्रोजेक्ट क्रिएट करना पड़ेगा. मैं क्या कर रहा हूँ, एक ही प्रोजेक्ट में मैं हैव क्रिएटेड मल्टीपल assembly files and then as an how I need them I'm adding it to my resource group and I rebuilding it and generating hex files. Okay, so this hex file has been generated now and I have added this controller over here. So how do we operate this software? I'll tell you first. So here also you open this, create new project. Okay, and click on schematic capture. And in schematic capture there are multiple modes. Okay, so go to this component mode and in this component mode you click on P and here you add the devices. Basically now I've added 8089C51 ka microcontroller. So 89C, you see 8089C51, I click OK, then it gets added over here. Okay, and I paste it here basically like this. Okay, I basically draw my circuit diagram here and I put my hex file in it. Then I took blue color ka LED, okay, blue LED like this, okay. And since it's port one, okay, since it's port one, I connected it to port one, okay. Now let's modify it a bit, okay. I don't want it like this. I want multiple, you know, LEDs to be there, blinking at the same time. I'll create, okay, rotate clockwise, not like this. Yeah, this is fine. Wait, it's just not working. So we're just drawing it, okay? We're just drawing random, not random, but we're just making a drawing here. And I just want to show you the state of this port, okay? Okay, this connection is not happening. Okay, we have connected random 3 pins of my controller. Okay, now let me quickly connect all of these together and ground them. Okay, now then port operation input from port operators I have taken one ground. Okay, this different ground. Yeah, from terminals we have to take ground. Okay, and connect it to the circuit. Okay, zoom it and now much better. Okay, Now what I'll do, I clicked on this controller and I'm browsing my this file, okay, trials.hex. I have downloaded this, okay, in the controller, and now I'll run the simulation. See, this LED is blinking blue. Again it will turn off. Blinking, turn off. Blinking, turn off. See, it's working. You understanding? Are you following till here? Yes or no?
सर वो हेक्स फाइल कहाँ पे ऐड हुई?
डबल क्लिक किया इधर मैंने, ओके, प्रोग्राम फाइल में ब्राउज, ओके, trials.hex. I am already at this location, okay. So if you want me to go through all that trials, I have objects, and in objects I have trial.hex. This is how browse it and download it inside of this. Got it? See, it generated hex file here, creating hex file from object trials, which I put in here. Got it?
Yes, sir.
Okay. One more thing I want to show you guys here is, suppose, yeah, this generator, this is, yeah. Now, suppose we are generating a square wave at our output port. What we will do, how we'll generate square wave? We'll of course move high value to port, generate delay, again low value, right? Do you agree with me on this or no? How will we generate square wave? Some high value on port, okay, some delay, okay, then make it low. Again some delay on low value, okay, we'll again make it high, then again some delay, again low, again some delay. So this is how square wave will be actually generated on board, right? This is how square wave will be generated. So let's have a look if it is actually working. Okay, what we are doing in LED blinking, same thing. We are making port high, high, some delay, then low, some delay, high, some delay, low, some delay. Okay, this is what we are doing in LED blinking. So let's connect oscilloscope to one of the pins, and okay, I can even short it here and see how it works. I'll start simulation again. This yellow thing, see, it is changing. Let me adjust it a bit. See, now the delay is something that we don't know. Okay, how much is the delay getting generated? Otherwise, we would see perfect square wave. We are gonna code the perfect delays anyways. See, it is high. Okay, now it is low. Now it is high again. Are you following this? In the background,
Yes,
see,
sir.
LED is blinking. When it is blinking, you can see high pulse on the output port. Okay, so simulation tools are really important in electronics. Okay, so this is how basically we see whatever we are doing is right, and it will actually work on hardware. So if it's working here, it will work on hardware also. Okay. Let me stop it. This is one of the simulation. Okay, what else I can show? Binary. Okay, anyways, LEDs will blink if I show you binary ka code here. I have to connect 8 LEDs. Okay, what we'll do is it's 8 already. So far is the coding thing clear to you guys? Let me see your faces. Manage Windows on your displays. Okay. Uh, are you guys good with assembly? At least a bit. I mean, you don't need it in details, but basic instruction. Momita, clear?
थोड़ा बहुत clear है.
Okay. Okay. So, uh, you are following the instructions, right? You understood the meaning of instructions, right? Or
Yes,
let
sir.
me explain you one more code, okay? One more code, and then we'll start with timers and counters, okay? Very interesting bit.
Okay, sir.
It will go a bit difficult for you to understand in the beginning, but I mean, we are going to start with timers and counters today and SFRs, okay, which is special function register. So timer and counter has this two SFRs, which is tmod and tcon. We need to configure those in order to have our timer or counter started in any specific mode. So we're gonna have a look at that as well today. So before we go there, we'll explain you one more code, okay, which I already explained to these guys, okay, and then we'll take 5 minutes of break and then we'll start Tmod Tcon with fresh mind. So this is another code in assembly itself, okay. Now before we actually start looking at the code, let me tell you what this code is doing. It is uh, so this is my port, okay, 8 pin, 1 2 3 4 5 6 7 8. तो ये कोड क्या कर रहा है, 0 to 10 numbers, I mean 10, I mean 0 to 9 will be 10, are you getting me? 1 to 10 is again 10, but 0 to 9 is also 10, okay. So this is 0 to 9 basically. So it will display these numbers on the port, okay. First it will display 0 0 0 0 0 0 0 0 0, okay. Then it will display 1, then 2, then 3, then 4, and 5, and 6, and 7, and 8, and 9, and 10. Okay, so like this, it will go on increasing. So how it is gonna happen? This this is what we have said. We are moving 0 AH to R3, means we have R3 has 10 now. Okay, in decimal. Okay, R3. Sorry, R3 has 10 in decimal. We are initializing the counter. Then and then we are moving 0 to accumulator. Okay, we are initializing accumulator here. Then accumulator का value port 0 पे डालो. This is port 0. Okay, port 0 output port we are considering port 0. So port 0 पे accumulator का value डाला मतलब 0 accumulator पे गया. Then we have called delay loop we already understood. Okay, delay में हमने क्या किया, different registers में हमने कुछ value load की है and we have decremented that value and we are jumping in the loop until this is getting decremented. This is how we are generating the delay. So what we did, accumulator का वैल्यू पोर्ट 0 पे डाला. accumulator में क्या था, 0 था, तो पोर्ट 0 क्या हो गया, 0 हो गया. Okay, and then we call delay, then that 0 state will be maintained for a while. If we don't call delay, that will not be maintained. You won't even see that the value is there on the port or no. That's why we are introducing delay, to see it with our naked eyes. Okay, then we are incrementing the accumulator. Now accumulator was 0 first. Now increment accumulator by 1. This instruction will increment accumulator by 1. Now accumulator will be 1. Okay, accumulator में अभी 1 आ गया. ठीक है. Now what it says DJNZ R3 and jump to again. R3 में क्या है 10 है. ठीक है. R3 में 10 है तो अभी DJNZ डिक्रीमेंट एंड जंप इफ नॉट 0. सो R3 डिक्रीमेंट होगा. फिर R3 में क्या आएगा 9 आएगा. Is 9 equal to 0? No. So it will jump to what? The label. What is my label? Label is again. Again में क्या है फिर से एक्यूमुलेटर में जो भी पड़ा है वो पोर्ट 0 पे भेज दो. एक्यूमुलेटर में क्या पड़ा है अभी 1 पड़ा है. सो पोर्ट 0 हो गया 1. आगे समझ में. पोर्ट 0 पे पहले 0 था. अभी पोर्ट 1 पे क्या डिस्प्ले होगा 1 डिस्प्ले होगा. Like this 0 0 0 0 0 0 0 1. This is one in binary. Okay, don't get confused. How come this is one? Okay, this is one in binary. पोर्ट 1 पोर्ट 0 पे मतलब आउटपुट पोर्ट पे 1 आ गया अभी. ओके, अभी क्या होगा फिर से डीले कॉल होगा टू रिटेन दिस फॉर अ व्हाइल. ओके, आफ्टर वी रिटेन दिस अगेन इंक्रीमेंट. यस, यू आर सेइंग समथिंग. ओके, सो अगेन वी इंक्रीमेंट एक्यूमुलेटर. एक्यूमुलेटर पहले पड़ा था 1. अभी मेरा एक्यूमुलेटर में जाएगा 2. ओके, accumulator में आ गया 2. then DJNZ R3 and jump to again if not 0. R3 में क्या पड़ा था 9. अभी R3 में क्या आएगा 8 आएगा. ओके, R3 में आ गया 8. is 8 equals to 0? No. It will jump to again. What again is saying? accumulator में जो भी पड़ा है वो आउटपुट पोर्ट पे भेज दो. accumulator में क्या पड़ा है 2 पड़ा है तो मेरा पोर्ट 0 पे चला जाएगा 2. ठीक है. Again to retain this for a while we are calling some delay here. Okay, so this is how it is working. So 1 2 3 4 5 until when? Until my R3 becomes 0. R3 में 10 मूव किया है मैंने. So 10 वैल्यू डिस्प्ले होंगी पोर्ट पे. ये कोड समझ में आ गया इधर पीपीटी पे? yes or no?
Yes, sir.
Yes, sir.
Okay, so now let me remove the existing. Wait, I'll need to remove this file from the source group and I'll add this binary number की file. Okay, in the source group and I'll build this. Okay, it got built. Now we'll see if it is actually displaying it on port 0 or no. See 0 1 2 3 4 5 6 7 8 9. Got it? Got it? 0 to 9 means it counted 10 numbers actually. Are you getting? 1 to
Yes.
10 are also 10 numbers and 0 to 9 are also 10 numbers. But it starts from 0. That's why suppose you wanted to display 10 also, then you would do, you will load this value with what? 0 A के बाद क्या आएगा hexadecimal में? Anyone can tell me? हेक्स में 0 A के बाद क्या आएगा? 0 A is what?
Sir, 0B.
0 B आएगा. ठीक है, मतलब A B C D E F G H H तक जाता है वो. ठीक है, and then 10 आता है 1 0. So this is how hexadecimal conversion works. Okay, so let's take a break of 5 minutes and we'll start with timers and counters. Okay, okay, let's take a break and be back quickly. Why my camera distorts? I just don't understand. Suddenly changes the way I look. Okay, anyways, we'll see you guys. Bye. Hey, why do I feel Kuber is not moving? He just he moved. Okay. I thought you're asleep. You're on mute.
No, sir, no, sir. I was not sleeping.
Okay. No, you were like this. I thought you have made video of yourself and put it in front of your camera so that I get a feel that you are sitting. But fine. Finally you talked. Okay. So take a break now. Okay. And be back in 5 minutes. We'll start timer counters. Hey, are you guys back? Okay, wait 2 moments. You guys are back, right? I shall wait for the Are you guys back? Others? If yes, turn your cameras on. Thank you. Okay, let's start. Let's start with tabs. So basically, see, our controller is having two timers or counters, right? T0 and T1. Okay, these both are 16-bit timers. Okay, 16-bit timers. Now, what do I mean by 16-bit timers? So let me share with you my screen, and you got to tell me like what you can see. Well, can you see me writing on the screen?
Yes, sir.
Yes, sir.
Okay. It's when we sometimes share window, it is not possible. So it's with PPT, I guess. So anyway, so uh timer 0 and timer 1 1. Okay. Both of these are 16-bit timers. Now I would say one more word, 16-bit up counters or timers. Okay, up counters मीन्स टाइमर में भी क्या होता है, पल्सेस काउंट होती है, ठीक है, जो भी क्लॉक साइकिल्स तुम्हें मिल रही है ना, हाउ डज इट काउंट, it counts the pulses and it calculates, I mean, the desired delay based on these pulses. Okay, so basically when I say it's a 16-bit timer, okay, when I say it's a 16-bit timer, how much will be the maximum delay I can generate? The 16-bit is the maximum it can go, right? So again, 65,536. Okay, this is the maximum number we can load into our register for counting purpose. Okay, because it's a 16-bit timer. So this is the maximum number we load, and I mean to count. I mean, this is the number that will be counted. How that will happen? Let's see that now. Okay. So I just mentioned you that timer 0 and timer 1 both are 16-bit timers. So now whatever we discuss, okay, whatever we discuss after this will apply to both timer 0 and 1. Even if I just say timer 0 or timer 1, it applies to both. Okay, everything will be similar for both of them. Both of them. Okay. So timer 0 or timer 1 both get divided further into T H0 and TL0. Similar for timer 1, TH1 and TL1. So what is this TH0 and TL0? So these are 8-bit registers, okay, and this is again 8-bit. So combiningly it will be 16 bits, okay, 0 to 7, okay, again 0 to 7, okay. These are 8 bits and this is 8-bit. Combiningly it has become what, 16, sorry, 16 bits, okay. So timer 0 and timer 1 get further divided into TH0 and TL0, okay, means higher bits and lower bits. So here 0 to 7, 0 to 7 means here it 8, combiningly 16 bits. So this number will be loaded in here and that number will be counted in incremental phases, and then it will, generate a delay according to this. I mean, for counting these many numbers, it will take some time, right? And that time is nothing or nothing but a delay that we're gonna be needing. Okay, this is one of the method to generate a delay or generate a waves of a constant frequency that we know of. Okay, timer and counter. Now I'm saying timer or counter. Okay, all the times I'm saying timer or counter. Then what's the difference? And when my controller operates as a timer and when as a counter, okay, so we'll see that. So timer is when we basically are counting this internal pulses, okay. Timer is when we are counting this internal pulses, and counter is when we are counting external pulses, okay. External means we have two pins, right, T0 and T1. This is the pin out of a microcontroller, and we have two pins T0 and T1. So these two pins, if we are feeding input by these pins, then it will operate as a counter. And we have a TCON register, okay, timer control register, to control its operation, okay. TMOD and TCON, there are two registers which we are going to study now. But is this clear so far, the basic theory of timers, like timer 0 and 1, both, I mean, they are 16 bits but further get divided into TH0 and TL0, okay. What is difference between timer and counter? What is the maximum number that we can load into TH0 and TL0 to generate delay? So are these things clear at least?
Yes, sir.
Okay, thanks for confirming. So now let's talk about TMOD. TMOD register, okay. Can you see some, what do you see on my screen right now? I just pasted one image. Can you see that?
So that timer 1
Yes,
mode
sir.
and timer 0 mode.
Okay, fine. So this is TMOD, okay. This is an SFR, okay. This is called TMOD, timer mode register. This is one of the SFR. SFR means what? Special function registers, okay. So while studying the memory thing in our controller, we saw there was a memory reserved for SFRs. SFRs are what? Special function registers. So we are moving to that area now. We are starting with our SFRs, okay. So this is our first SFR that we are studying, timer mode, okay, TMOD register. There is similar to this called TCON, timer control. So we'll see that as well, okay. So TMOD कैसे काम करता है? So there are this is 8-bit, okay. Again 0, 1, 2, 3, 4, 5, 6, and 7, okay. I guess the count initiates from here actually, okay, officially. Okay, so and this is not a bit addressable, okay. This is not bit addressable. We have to address it with tmod like this, like move tmod and whatever the value you want to move, okay. That's how you move certain value into tmod. Okay, so let's see function of each and every bit. Okay, so first 4 bits timer 1, for next 4 bit timer 0. So anything and everything that I talk about any timer will apply to both of them. Okay, so let's talk about this gate first. Gate C or T bar M0 M. Okay, let's do it this way. We'll talk about C or T bar first. So this C or T bar. Any guesses what it could be? Wild guess, guys. Anyways, counter or timer. Okay, the mode of operation, counter or timer. Now, when I set it as 1, it will operate as counter. When I set it as 0, it will operate as timer. Okay, so when we are sending value to tmod, okay, when we are sending a value to tmod, we have to design it like this first. How do I want to operate? Okay, which mode do I want to operate? What should be the status of the gate that I want to operate on? So we should design it such a way, and then we send the value. Okay, how do we program timer or counter? The steps are basically, first we move certain value to tmod to select the mode, then we set we do certain operations, then we set tcon. Okay, tcon is bit addressable, so we can address tcon directly, like move tcon dot phi is equal to 0 x ffh. Like this we can do with tcon, but not with tmod. So tmod has to be designed certain way and then worked on. So what happens is that, now say we want to use it as a timer, so I'll keep it 0. Okay, I'll keep this C or T bar 0. Then what is this gate now? Gate. So there are certain ways and there are certain conditions we want to set, okay, for our timer or counter. So suppose I want my timer to start only when there is an input, external input provided. Okay, suppose I want to start timer on external input. Okay, so you see this pin called int0 and int1, right? You've seen this pin, right? int0 and int1 in the block diagram of in the pinout diagram of microcontroller, right? Yes or no? int0, int1, you have seen these pins,
Yes,
right?
yes, sir.
Yeah. So this gate says that how do I want to start my timer? Suppose I say I want my timer to only start when there is an input at this pin, there is an interrupt at this pin, int0. Then I'll operate on gate 0. If I want to start my timer when there is an input at int1, then I'll operate with gate 1. So if I set this gate as 1, okay, if I set this gate as 1, it means that timer will not start until the interrupt is coming from external pin. Okay, if I'm setting it 1, then it will wait for this pin. Okay, it will wait until int x, I'm saying int x 0 1 whatever. Okay, int x is getting some input. Okay, interrupt. So this is how it works. So far clear? These two pins, not pins, these 2 bits of this SFR are clear. Okay, I repeat. So CT bar means counter or timer. Okay, is this clear at least? If I select 1, I'm saying that operate this timer as a counter. If I'm selecting 0, I'm saying operate this timer as a timer. Are you clear with this? Yes or
Yes,
no?
Yes, sir.
Then gate. Okay, gate is basically something ki int 0 या int 1 पे कोई input आएगा तभी ये चीजें काम करेगी. Okay, we are programming it such way कि interrupt आने पर ही ये start कर. Okay, this is that control. So if I don't want that, I will simply set it as 0. Okay, so we've decided on two values so far. If I want to operate my controller as a normal timer, okay, so मैं क्या बोल रहा हूँ, मेरा gate 0 चाहिए, मेरा timer C and T bar भी 0 चाहिए. ठीक है. Now what is this M0 and M1? We'll see that. These are modes basically. So M0 and M1. ये जो है ना वो टाइमर के मोड्स होते हैं कि टाइमर you which mode you want to operate your timer in. So far you know that our timer is divided into again two registers, right? Two 8-bit के registers, TH0 and TL0, or I will say THX and TLX, means 0 1 whatever it is. 8 बिट के दो रजिस्टर्स है ये. ठीक है. So this mode will tell us which I mean M0 M1 will tell us which mode our controller is gonna operate in. Okay, so 0 0 0 1 1 0 1 1. This is how we select the mode. Okay, in 0 0 0 1 1 0 and 1 1, all this is having four different modes. For mode 0, it is going to operate as a 13-bit, basically 13-bit timer or counter. Okay, 13-bit timer or counter means all these 8 plus 5 bits of this. Okay, all these 8 will be considered in counting, and 5 bits of THX. Okay, then mode 1, this is mode 0. Okay, let me name it first. Mode 0, mode 1, mode 2, and mode 3. There are total 4 modes like this. First one is 13-bit timer or counter. Second one is 16-bit timer or counter. It is 16 bits, means everything will be consumed, and majority mode 1 will be used because there we have maximum count available. Okay, how much did I tell you? 65,300, 65,635. Okay, 2 raised to sorry 60, 2 raised to 16. Okay, then mode 2. Mode 2 is different. Mode 2 is what? It's basically 8-bit auto reload timer. Okay, now don't go by these words. Okay, 8-bit auto reload, we mostly don't require all these mode. I will still explain you. And last is function depends on timer 0 or timer 1. Okay, is mode 3. This function is not really specified, it depends. I'll explain you this later. Okay, so these are four modes: 0 0 0 1 1 0 1. So what I said you guys, what I told you is we are mostly going to use mode 1 because it's a 16-bit timer. Okay, 16-bit timer or counter mode, that is what we needed. Okay, to have most of the count so that we can generate the maximum delay. So what are values of mode 0 and mode 1? M0 and M1 bit, 0 and 1. Okay, 0 and 1. So what all we have decided on so far? We decided gate ka value, C or T bar ka value, M0 and M1 ka value. Okay, so I'll select mode 1 here, equal 0 1 हो गया. Okay, और if it is from here it will be उल्टा 0 मतलब 1 0 हो जाएगा अगर इधर से काउंट किया तो. ठीक है. So Tmod is similar. Okay, T1 and T0, both for both of this it is similar. So is Tmod clear to you guys?
सर
So
थोड़ा
suppose,
थोड़ा है
yeah, please tell me.
सर थोड़ा थोड़ा है समझ में एकदम अच्छे से नहीं हो
ठीक है, मैं एग्जांपल देता हूँ ना, तुमको समझ में आ जाएगा, डोंट वरी. Suppose I want to operate my controller, okay, in suppose I want to configure timer 0 in 16-bit timer configuration, okay, and timer 1 again 16-bit but counter configuration, okay. Then how will the values be? Okay, my statement is what? Set timer 0 in 16-bit timer configuration and set timer 1 in 16-bit counter configuration. Okay, now let me start putting in the values so that you understand. Okay, yeah, M1 and M0. Okay. 0, 0, okay, 0, 1 करेगा ये. Okay, so first thing first, timer 0 का पहले देखते हैं. ठीक है, I have to configure timer 0 in 16-bit timer mode. So timer 0 का ये वाले बिट्स है. ठीक है, so M0 and M1 C/T bar, मुझे टाइमर कॉन्फ़िगर करना है इधर, तो मेरा C/T bar ऑफ कोर्स क्या रहेगा? 0 रहेगा. गेट क्या रहेगा? 0 रहेगा, क्योंकि मुझे टाइमर से ही यूज करना है, मुझे कोई एक्सटर्नल इनपुट नहीं चाहिए टाइमर स्टार्ट करने के लिए. So my gate will be 0, C/T bar will be 0, M0, M1. Now my modes, okay, I want to operate it in mode 1. Mode 1, so I will select it as 0 1. Okay, 0 1. Okay, now I want to set my timer 1 in 16-bit counter configuration. So again, gate, let's keep it 0 to make it to keep it simple. Then counter or timer. Now I want this to be 1 because I want it to operate as a counter. Now again 16-bit counter करना, तो 16-bit के लिए फिर से 0 1. Okay, got it. So you will load this value to tmod. Okay, move, you will say move tmod कितना? 0 1 0 1 0 0 0 1. You can directly load this value. Okay, or you can convert it into this thing. Okay, now how much is this? This is 1 2 3 3 and 1. This is 4, I guess. Yeah, this is 4. No, it's not 4. This is 0 0 0 1 1 0 3. This is, yeah, this is 4 only. No, this is 5. Okay, this is 0 to 4. This is 5. So 5 and 1. Okay, so you will move tmod में तुम लोग ये value move करोगे 5 1. Okay, and I guess you will write correct. It will be like this. Okay, so you will move this value to tmod, then these modes will be operated. Is this clear? You can directly write like this, or you can convert it further and then move it. Is this clear?
yes sir
Okay, okay. So let's move to tcon now, because tmod and tcon का operation ना combiningly ज़्यादा अच्छे से समझ में आता है, क्योंकि these two are like closely linked to each other and erasing everything. We just paste tcon from somewhere. So what do you see on the screen right now?
Sir, the TCON register.
Okay, you're able to see it, fine. So tcon में भी mostly ना दोनों के bits होते हैं, ठीक है? दोनों के bits you will find. Okay, value on reset is of course 000. This is LSB, this is MSB. ठीक है? So tcon में TF1, TF0, TR1, TR0, I1, I0, IT1, IT मतलब 0 1 रिपीट ही है मोस्टली. ओके, तो 4 बिट्स से तुम्हें करना है थोड़ा मतलब फंक्शन अंडरस्टैंड करना. रेस्ट 4 का हो जाएगा अपने आप. सो TF1 and TF0. So this is TFX. I'll write TFX. Okay, this is timer overflow bit. Okay, overflow bit. So when my timer is going to overflow, these bits will be set to 1. Okay, and we will read the status of this tcon. Okay, we will read it. Okay, and we'll decide. I mean, we'll see, we'll check, we'll keep checking continuously if TF0 is set, if TF1 is set, and if that is set, then we will take action accordingly. Okay, we'll reload the timer or we'll do whatever is appropriate action. So this bit sets to 1 when timer overflows. Okay, it sets to 1. It sets basically. Okay, set means 1 and reset means 0. So set, it sets when overflows and timer overflows. Okay, this is TF1 and TF0. Now TR1 and TR0, what is this? Okay, so TRX, right? So TRX में क्या होता है, मतलब TR0 and TR1. So when so we have to suppose I have written a code, I have configured my timer. Now I want to start it. Okay, I've explained you earlier, there are two ways I can start it. I mean, there is this gate thing. Okay, gate में क्या कर रहे हैं हम, अगर external input आया, अगर external input आया and TR1 and TR0 is set to 1, then only start the timer. Okay, now what I'm saying is, even if the gate is 0, I don't want external input, as a criteria for my timer to start. Okay, I just want to control it with TR and TR, I mean TR0 and TR1. मतलब ये it's like a push button. Okay, जैसे तुम लाइट का बटन दबाते हो लाइट चालू हो जाती है, तो वैसे ही ये है. जैसे तुम TR1 and TR0 सेट करोगे, टाइमर का काउंटिंग स्टार्ट हो जाएगा. ओके, so when we set it to 1, it starts the timer. Okay, starts the timer or counter. And when it is 0, it halts the values. Okay, understood so far? TF and TR clear?
Yes, sir.
Okay, so TF में क्या हो रहा है, overflow flag है वो, it is like a flag. So when the timer is overflowing, okay, when it is going to FFFFH, then this bit will be set. Then we'll keep polling in the code. If TF0 is FFFH, if it is FFFH, then start the counting again or stop the execution of the code. Anything we can do. Okay, this is what we are checking it for. Okay, then TRX means TR0 and TX0. So sorry, TR0 and TR1. So it is a start button. Okay, तो मैं बोल रहा हूँ कि अगर इसको ये 1 है तो स्टार्ट कर दो, 0 है तो कुछ मत करो, ठीक है, हॉल्ट करो वैल्यू. नाउ IE, now IE0, IE1. Okay, IE0 and IE1 देखेंगे, ठीक है. So I and IT. So don't get confused in between these two. Okay, I is basically when. Okay, let me write IE1 and IT1. IEX. Okay, so what I'm saying here is that jab interrupt I is actually a bit in SFR when interrupt is received at int 0 and int 1 pin. Okay, this bit sets to 1. Okay, basically it becomes 1. I mean, or it sets itself. Okay, it becomes 1 when interrupt arrives. Okay, when interrupt arrives, int INT पिन पे जब इंटरप्ट आता है तो ये 1 हो जाएगा, ठीक है. और ये 0 कब होगा? जब ISR एग्जीक्यूट होगा. ओके, ISR एग्जीक्यूट होने के बाद ये फिर से 0 हो जाएगा. तो मैंने तुम्हें इंटरप्ट का ऑपरेशन बताया, ठीक है. सो दिस इज इंटरप्ट एग्जीक्यूट का बिट. ओके, सो इट सेट्स टू 1. Okay, it sets to 1 when there is an external interrupt. Okay, when there's an external interrupt. So on receiving the interrupt, what controller does is jumps to ISR. Okay, it jumps to interrupt service routine, and when that interrupt service routine is executed, it again becomes 0. Okay, understood? Then IT1 and IT0, ITX basically. So what ITX means is that we are configuring what should be the type of interrupt. Okay, if it should be level trigger or edge trigger. Okay, so if I'm saying it is set to 0, if I or 1, okay, it has two different meanings. So if I'm setting it to 1, it is negative edge triggered interrupt. Negative edge triggered interrupt. Now what is negative edge triggered interrupt? I'll tell you. Okay, don't get scared by the name. So interrupt is basically something that is interrupting the regular execution and then executing the ISR, right? So what is the trigger of that interrupt we want? Okay, ये हमारा controller है, इसमें we have INT0 and INT1. These are external interrupt pins. Okay, so इस पिन पे ऐसे कोई तो सिग्नल आएगा, बेसिकली इंटरप्ट. सो लेवल ऑफ दिस सिग्नल वी आर डिसाइडिंग कि इस सिग्नल में भी कौन से लेवल पे इट शुड कंसिडर इट एज एन इंटरप्ट. ओके, what level of this signal should be achieved in order to consider it as an interrupt. Okay, we are talking about that now. Okay, so if this bit is set to 1, if this bit is set to 1, it is negative edge trigger. Okay, it is negative edge trigger. मतलब जब ये fall होगा. Okay, when basically interrupt has to be negative edge trigger interrupt, and when it is cleared, I mean when it is 0, it has to be low level trigger. Okay, so when it is moving down, when it is moving down, it's called negative edge trigger. Okay, and there is this trigger. Okay, this trigger is, what is this called as? This is low level trigger. Okay, low level trigger. तो इधर हम कॉन्फ़िगर कर रहे हैं कि मुझे कौन से लेवल पे अपना इंटरप्ट कंसिडर करना है एज एन इंटरप्ट. आर यू अंडरस्टैंडिंग? if I'm setting this pin 1, okay, if I'm saying this IT0 and IT1, if I'm setting this IT, okay, Why this not coming? If I'm setting this, oh, what is? Wait, there's something wrong. Okay, let me reshare. Do you see the whiteboard again?
Yes, sir.
ओके सो मैं जब IT0 टीकॉन में IT0 में 1 सेट करूंगा तब क्या होगा? तब मैं बोल रहा हूँ कि my interrupt should be negative edge triggered. When I am setting IT0 is equal to 0, I am saying my interrupt should be low level triggered. Okay, are you understanding this? I mean concept जाने दो, basic समझ में आ रहा है ना कि बस मुझे bit set करने हैं and accordingly my timer or counter will operate. आ रहा है समझ में?
Yes, sir.
Okay, thanks for confirming. Now, this overall I will explain. Okay. Oh God. I'm so- Okay, so TF0, TF1. It is basically the timer overflow bit. तो let me explain you how timer overflows. Okay, तुम लोगों को ये question आना चाहिए था कि overflow कैसे होता है, क्योंकि मैंने बहुत सारी contradicting चीजें बोल दी है. If you guys have noticed कि मैंने क्या बोला पहले, तो हम TL0 और TH0 जो मतलब हमारा टाइमर 0 and 1 स्प्लिट हुआ है 8 बिट्स में, उसमें कोई तो वैल्यू लोड करेंगे एंड वो वैल्यू काउंट होंगी, राइट? अप काउंटर, आई आल्सो मेंशनड इज एन अप काउंटर. then I mentioned we load some value into these registers, and if मैं value load कर रहा हूँ तो how will it overflow, right? Don't you guys have this question like why this overflow flag? Why will it overflow? You should ask such questions. You should have such questions, right? So let me explain you that. So overflow क्यों होता है, नहीं कब होता है? Okay, so how our timer basically works is that I told you कि हम वैल्यू लोड करेंगे दो रजिस्टर्स में, लेकिन ये लोडेड वैल्यू काउंट कैसे होती है और ये वैल्यू होती क्या है एग्जैक्टली, ठीक है? सो मेरा प्रॉब्लम स्टेटमेंट ऐसा है कि जनरेट द डिले ऑफ 20 माइक्रोसेकंड, ऐसे स्टेटमेंट्स होते हैं एट पोर्ट 0. ओके, ये मेरा स्टेटमेंट है. तो ये 20 माइक्रोसेकंड के लिए मुझे कैलकुलेट करना है TL0 एंड TH0 की वैल्यूज. ओके, इसका एक सीक्वेंस ऑफ स्टेप है जो हम कल पढ़ेंगे, ठीक है? आज नहीं पढ़ाऊंगा मैं, आज बहुत ज्यादा हो जाएगा. सो सॉरी बट या सो ये 20 माइक्रोसेकंड का डिले जनरेट करना है, उसके लिए मैं TH0 एंड TL0 के वैल्यूज कैलकुलेट करूंगा, ठीक है? उसके 1 2 3 4 5 6 स्टेप्स है. ओके, एंड last step I'm gonna tell you right now because that only explains how this works. Okay, so मैंने तुम लोगों को क्या बताया था कि 65,635 something is the maximum number that comes, right? Yeah, 65,535. Okay, 535. So ये जो steps हम लेंगे, okay, इसके एंड में कोई तो नंबर आएगा, राइट? एक नंबर पे हम पहुंचेंगे, तो वो जो नंबर होगा, ओके, दैट नंबर वी विल डिडक्ट फ्रॉम द मैक्सिमम नंबर। ओके, तो सपोज ये 65,535 नंबर कब अचीव होगा? जब ये सारा 1 1 1 1 1 1 1 1 1 होगा। ओके, एंड दैट इज व्हेन आवर TF बिट्स विल बी सेट। ओके, TF0 विल बी सेट। सो ये सब 1 1 1 1 होगा, तब TF0 सेट होगा। ओके, सो मुझे मैक्सिमम डिले तो नहीं चाहिए। मेरा स्टेटमेंट ऐसा है क्या कि जनरेट द मैक्सिमम पॉसिबल डिले यूजिंग टाइमर 0। अगर वो होता तो मैं सीधा इसमें वो 0 0 0 0 लोड करता, देन माय काउंटर विल स्टार्ट काउंटिंग फ्रॉम 0 to 1 1 1 1 1, राइट? एंड देन माय TF0 bits will be set, right? But my statement is generate delay of only 20 microsecond. तो 20 माइक्रोसेकंड के लिए मैंने कैलकुलेशंस की है। अब ये ओवरफ्लो कैसे होगा? तो मैं 65,535 से माइनस करूंगा ये वैल्यू, सपोज दैट वैल्यू इज ए। ओके, सो आई एम डिडक्टिंग 65,535। ओके, इससे ये ए डिडक्ट किया, फिर जो भी वैल्यू आई, सपोज द वैल्यू केम आउट टू बी 60,000। ओके, तो मैंने 60,000 इसमें लोड किया, और जब मैं TR0 सेट करूंगा, मतलब मैं बोलूंगा कि काउंटिंग स्टार्ट करो अभी, तो ये काउंट स्टार्ट होगा 60,001, 60,002, 60,003, 60,004, और ये कर करके ये एंड में कहाँ तक पहुंचेगा? 65,535। तब मेरा TF0 और TF1 सेट होगा, मतलब टाइमर मेरा ओवरफ्लो हुआ है। आर यू अंडरस्टैंडिंग कि हम काउंट कैसे लोड करेंगे? हम डिडक्ट करेंगे वैल्यू, ठीक है? मतलब टू गिव यू सिंपल एग्जांपल, एक नोटबुक कंसीडर करो। ओके, नोटबुक कंसीडर करो। एक नोटबुक के आखिरी पेज में जाओ, नोटबुक के आखिरी पेज में जाओ, और तुम्हें बस क्या करना है? तुम्हें लास्ट के 10 पेज काउंट करने हैं। तो तुम काउंट कैसे करोगे? पहले तुम अगर नोटबुक तुम्हारी 200 पेजेस की है, तो यू विल गो एट 200th पेज। ओके, then you will deduct 200 minus 10. Okay, because you have to count last 10 pages. 200 minus 10 is 190. So ये 190th पेज ओपन करोगे तुम। ऐसे काम करता है हमारा टाइमर। ओके, you will be on 190th page, and from there you will count 10 pages. Okay, and then on reaching 200 your timer will overflow. Are you understanding? I mean, because your maximum count is 200, because this is a 200 पेज का नोटबुक। आ गया समझ में? नहीं ना? नहीं समझे ना?
सर बेसिक समझ गया है।
क्या समझ में आया मेरे को बताओ तुम, थोड़ा
सर
थोड़ा।
मतलब जो TH0 और TL0 रहते हैं, तो ये ओवरफ्लो तब होते हैं जब मतलब सारे डिजिट्स 1 हो जाए। और अगर मतलब डीले जनरेट करना हो तो उसके लिए फिर जो 65,535 है उसमें से ए माइनस करना है, और मतलब ए जितनी वैल्यू है उतनी माइनस करनी है। और फिर जो मतलब टी आर जीरो को मतलब 1 करना है, तो उससे मतलब काउंट स्टार्ट होगा। और फिर काउंट स्टार्ट होने के बाद जो मतलब ए माइनस करने के बाद जो वैल्यू आई उसको फिर इंक्रीमेंट करना है 65,535 तक, और फिर वो फुल हो जाएगा। और फिर मतलब ये होगा क्या
TF0 सेट
ओवरफ्लो
हो
होगा,
जाएगा,
ओवरफ्लो हो
ओवरफ्लो
जाएगा।
होगा। राइट, या
हाँ
यू गॉट इट राइट। ओके, सो लेकिन बेसिक्स क्लियर रखो बस। ये इतना हम क्यों कर रहे हैं? मतलब हम डायरेक्टली, तुम लोगों के दिमाग में ये भी सवाल आना चाहिए कि मुझे 20 माइक्रोसेकंड का डिले जनरेट करना है, और मैंने एक वैल्यू कैलकुलेट की है TL0 TH0 की, तो वो वैल्यू डायरेक्टली क्यों नहीं मूव कर रहा मैं इसमें, है ना? 20 माइक्रोसेकंड के लिए जो वैल्यू होती मैं इसमें लोड कर दूंगा, इतना डिले भाई तू कर ले काउंट, है ना? उसका रीजन ये है कि दीज आर अप काउंटर्स। ओके, मतलब इट विल ओनली काउंट अपवर्ड्स। ओके, तो अगर मैंने यहाँ पे 20 माइक्रोसेकंड की वैल्यू होती है, समझ 40,000 इट्स अ वैल्यू। ओके, तो अगर 40,000 मैंने लोड कर दी इधर, तो 40,000 टू 65,000 इज 20,000, मतलब ये ज्यादा डिले नहीं हो जाएगा अप काउंटिंग करते करते करते, राइट? सो हमने किया क्या, जो मैक्सिमम डिले है अपना 65,000 का, उसमें से ये वैल्यू माइनस की, तो वो जो वैल्यू है उतना ही काउंट करेगा ना। आ रहा है समझ में? suppose this a is 2000, then it will become 63,535. तो इसको बस 2000 नंबर काउंट करने आगे के, because that is what we need for 20 microsecond. We don't need 63,000 to be counted, we only need 2000 to be counted. How are we achieving this? We are deducting it from 65,000. 65,000 से मैंने 2000 डिडक्ट किए, एंड फिर 63,000 से मैंने 2000 तक इंक्रीमेंट किया, 1 1 1 1 1, एंड देन वो इंक्रीमेंट होते होते जब सेट हो जाएगा, जब वो पूरा भर जाएगा, पूरा 1 1 1 हो जाएगा, तब TF0 and TF1 will, I mean TF0 और TF1 will be set, okay? एंड ये हम प्रोग्राम में पोलिंग करेंगे। इसका एक सैंपल कोड दिखाता हूँ, इट विल बी मोर क्लियर टू यू गाइस। What do you see on screen? Do you guys see anything on the screen?
Sir, the screen is not visible.
Awesome. It's
Okay,
not
okay,
shared.
because I'm not sharing. मैं वो कोड ढूंढ रहा हूँ, ओके? दैट इज एन इजी, बेसिकली टाइमर कॉन्फ़िगरेशन का कोड, ओके? Okay, so let me share my screen now. Will finally code, which so many codes, actually it's difficult to find one out of many. So what do you see on my screen right now? Are you seeing this code on my screen right now?
Yes, sir.
Okay, तो यहाँ पे हो क्या रहा है? तो ये जनरेट कर रहा है स्क्वायर वेव, बट दिस टाइम डिले कैसे लिखा है देखो तुम लोग। पहले हम डिले कैसे लिखते थे, नॉर्मल रैंडम डिले जनरेट करने के लिए we were used to, I mean we used to move the random values into registers and we used to decrement that, okay? And that used to take some time, okay? So इधर हमने क्या किया है देखो, हमने पोर्ट 1 पे 0 0 किया है, मतलब पोर्ट 1 इज नाउ 0, देन डिले कॉल किया, देन पोर्ट 1 FFH किया है, मतलब 0 FFH किया, पहले 0 किया फिर 1 किया, मतलब 0 किया डिले किया, 1 किया डिले किया। तो डिले में लिखा क्या है देखते हैं, डिले में क्या किया, टी मॉड में 01H मूव किया है, ठीक है? मींस व्हाट इज दिस, कैन यू टेल मी नाउ, दिस इज इंटरेस्टिंग। मैं रुको, मैं वो पीपीटी भी शेयर करता हूँ सो दैट यू गाइस कैन रिलेट, ओके? मैं पूरा स्क्रीन शेयर करता हूँ, दैट वे इट विल बी बेटर। So this is my PPT, okay? ये कोड साइड में रखना है मुझे, टी मॉड एंड टी कॉन के, ठीक है। सो ये टी मॉड है हमारा, ठीक है। सो मैंने टी मॉड में मूव क्या किया, 01H, ओके। मतलब टाइमर जीरो का सब जीरो ही है, टाइमर वन हम यूज ही नहीं कर रहे। 01 मतलब गेट जीरो, गेट भी जीरो है, सी स्लैश टी बार भी जीरो है, राइट? आर यू फॉलोइंग दिस?
यस सर।
सी स्लैश टी बार भी जीरो है, मतलब टाइमर यूज हो रहा है इधर, और 01 है इधर, 01। 01 मीन्स मोड वन यूज कर रहे हैं हम, 16 बिट टाइमर और काउंटर। आ गया समझ में? मैंने बोला ना हम मैक्सिमम 01 यूज करेंगे, मोड वन यूज करेंगे हम मैक्सिमम। सो दैट इज दिस, ओके। तो ये इधर तुम लोगों को समझ में आ रहा होगा कि किया कैसे है एक्चुअली में। सो सो let me again take you to my whiteboard to explain you this. Let me remove this. Okay. Okay, so मेरा ये tmod है, वो सेट कैसे हुआ है कोड में? Copy this. Oh, great. Okay, so ये tmod रजिस्टर है, ओके। इधर व्हाट डिड आई डू, 01 मूव किया है। 01 मतलब ये ऑपरेट किस मोड में कर रहा है, ये भी आ सकते हैं क्वेश्चंस तुम्हें, ठीक है, कि ये कोड है, अब मुझे बताओ कि तुम्हारा टाइमर किस मोड में ऑपरेट कर रहा है, ठीक है। तो जी टी मॉड में 01 मूव किया है, मतलब देखो इसको स्प्लिट करना है तुम्हें, 0 and 1। फर्स्ट जीरो इज फॉर फर्स्ट 4 बिट्स, नेक्स्ट वन इज फॉर these bits, okay। So ये 0 0 0 0 है of course, and then 01 means 0 0 0 1, okay। इसका रीजनिंग भी पूछ सकते हैं तुम्हें कोई भी। गेट 0 0 क्यों है? We don't want external interrupt to be acting as an event for my timer to start, that's why it is 0। Then c slash t bar means I want it to operate as a timer, that's why it is set to 0। Then mode 1 and mode 0 का तुम्हें तो पता ही है, 0 0 0 1। 01 means mode 1, so I wanted to operate this in mode 1 so that it can be set 16-bit timer, okay। This is operating in 16-bit timer mode. Then I have loaded TL0 and TH0 with some value, okay। Don't focus on I mean the count, okay, just focus on some value, okay, some x value has been loaded here, ff and cc। TL0 is loaded with ff and th0, okay, TL0 and th0। So TL0 इधर है and th0 इधर है, तो TL0 FFFFF ऑलरेडी है, and TH0 में some value is there, okay, CC value है, CCH है, ठीक है। सो ये क्या करेगा, काउंट कैसे होगा, ये CCH है ना, ये FFH तक पहुंचने तक काउंट होगा ये, ठीक है। एंड देन वी आर डूइंग सेट बिट TR0। देखो आई टोल्ड यू दैट दिस इज अ बिट एड्रेसेबल, सो ये टीकॉन का है बिट है, TR0 इज फ्रॉम टीकॉन, ओके, इफ यू रिमेम्बर। TR0 में मतलब मैं आई एम स्टार्टिंग माय टाइमर 0, ओके, आई एम सेइंग स्टार्ट टाइमर 0, ओके। मैंने वैल्यूज लोड करी, स्टार्ट टाइमर 0 विद दिस कॉन्फ़िगरेशन, आर यू अंडरस्टैंडिंग नाउ? देन JNB TF0 हियर। नाउ हम वेट कर रहे हैं जब तक TF0 सेट नहीं होता, ओके। JNB का फुल फॉर्म है जंप इफ बिट इज नॉट सेट, ओके। TF0 सेट कब होगा, टीकॉन में है TF0, राइट। लेट मी पेस्ट माय टीकॉन आल्सो हियर फॉर योर अंडरस्टैंडिंग। सो ये मेरा टीकॉन है, तो ये सेट कब होगा, ये TF0 है, ठीक है। TF0 TF0 सेट कब होगा, जब टाइमर ओवरफ्लो होगा तब सेट होगा ये, राइट। Okay, very difficult to navigate through this whiteboard. Okay, so what I'm checking is set bit tr0 मतलब टाइमर स्टार्ट किया, उसके बाद jnb jump if bit is not set, which bit tf0. tf0 सेट कब होगा, जब टाइमर फ्लो मतलब ये काउंटिंग tx0 की भी खत्म हो जाएगी, तब ये सेट होगा, तब तक इधर ही वेट कर. हो गया डिले जनरेट, जब तक ये सेट नहीं होता तब तक. दैट्स व्हाई वी आर पोलिंग tf0. Okay, this is called polling method. There is another method called interrupt method, but this is polling. Okay, we are polling, we are checking for tf0 if it is still 0 or no. If it is not 0, then staying here only. Okay, then after that we are clearing tr0 and we are clearing tf0, means we are stopping the timer, we are clearing the tr0 wala bit. Okay, एंड वी आर क्लियरिंग द TF0, मतलब ये सेट हुआ है, उसको भी क्लियर करना चाहिए फिर से, राइट. सो ये 1 हुआ था, इसको 0 कर दिया, इसको TR0 को हमने इधर स्टार्ट कर दिया था, सेट बिट TR0 वो भी हमने स्टॉप कर दिया 1 to 0, मतलब टाइमर स्टॉप किया और ओवरफ्लो बिट भी क्लियर किया. देन रिटर्न एंड एंड. रिटर्न मतलब किधर जाएगा ये, डीले कहाँ से कॉल हुआ इधर, फिर क्या होगा, पोर्ट 1 पे FFH आएगा, पहले पोर्ट 1 पे 00 था, मतलब पोर्ट 1 पहले ऐसे था. ओके, फॉर दिस टाइम. नाउ क्या होगा, ऐसे लो हुआ, फिर डीले जनरेट हुआ. अभी मैं बोल रहा हूँ कि पोर्ट 1 को हाई कर, पोर्ट 1 को हाई किया, ठीक है, पोर्ट 1 हाई हो गया, फिर से डीले कॉल कर. डीले कॉल में लिखा क्या है, डीले में मैंने फिर से टी मॉड मूव किया, टी मॉड में मैंने फिर से वैल्यू डाली, फिर से TL0 लोड किया, फिर से TH0 लोड किया, फिर से सेट किया TR0 मतलब स्टार्ट किया टाइमर, फिर से वेट किया डीले जनरेट हो. अभी डीले जनरेट हो गया, ठीक है, सॉरी, डीले जनरेट हो गया, ठीक है, डीले जनरेट हो गया, ओवरफ्लो हो गया, फिर मैंने टाइमर स्टॉप किया, फिर मैंने ओवरफ्लो क्लियर किया और फिर रिटर्न जा रहा है. रिटर्न में क्या बता रहा है मुझे, रिटर्न पे फिर से क्या हो रहा है, SJMP अगेन. ओके, रिटर्न इधर डीले कॉल हुआ था ना, तो स्मॉल जंप अगेन, अगेन क्या है, फिर से 0 मूव होगा इधर, 0 हो गया, 0 होने के बाद फिर से डीले कॉल हो गया, हो गई वेव जनरेट. आर यू अंडरस्टैंडिंग? Tmod and Tcon clear? Yes, no, blank. Hello, good morning. Too much for the day, huh? Okay, then take time, okay? Absorb this, okay? Go through this Tmod and Tcon, okay? ये इनिशियली थोड़ा लोड देता है, लेकिन ठीक है, ये तुम्हें समझ में आ गया तो अच्छी बात है, नहीं तो भी अच्छी बात है. विल गो थ्रू इट अगेन, बट एटलीस्ट तुम्हारा मतलब थोड़ा आज एक्स्ट्रा हो ही गया. You people join also late, so that's fine. Any doubt, concerns, questions?